factor. Before you factor any polynomial, you first check for a greatest monomial factor. In this case, all three terms are divisible by 5. What is left over in parentheses has 3 terms. First thing I'm going to check for is perfect square trinomials, PST. This is a perfect square. It's 5u being squared. This is also a perfect square. It's 1 squared. Is this twice the product of these? Yes. Therefore, I can factor it as a perfect square trinomial. I'm going to put the 5 in front. What goes inside? My 5u from over here, my 1 from over here. I'm going to use a subtraction sign because the 10u is negative. Factor. The greatest monomial factor between all of these 3 terms, they are all divisible by 2. They all have a u. They do not all have a v. So this is my greatest monomial factor. Divided by 2u, divided by 2u, divided by 2u. I am left with 4u squared minus 12uv plus 9v squared. I have 3 terms left. First thing I'm going to check for is if it is a perfect square trinomial, PST. This is a perfect square, it's 2u squared. This is a perfect square, it is 3v squared. 2u times 3v is 6uv. Twice that is 12. So this does fit the pattern of a perfect square trinomial. Therefore, it can be factored to 2u, 3v. I'm going to use a subtraction sign. Final answer. Factor by looking for a perfect square trinomial. I have 4 terms here. There are 4 terms. We're going to cross our fingers and hope that 3 of those terms put together is a perfect square trinomial. And that is the case here. If you notice, here's a p squared, here's a p, here's a 4. These all seem related. And they are. Actually, this can be factored into p plus 2 squared. Bring down your minus q squared. What I have now is the difference of 2 squares, the dose rule. That means my p plus 2 goes in front. Q goes behind. This one's being added. This one's being subtracted. I'll take a look and see if I need to clean up any of my terms. I cannot combine any like terms, so I am done. Factor. I have 4 terms. I am crossing my fingers that somewhere there is a perfect square trinomial. The key here is that, well, here's a p, and there's no other terms with a p in it, so it's kind of off by itself. And I'm going to leave it off by itself. And I also have a subtraction sign here, so it tells me that everything probably beyond this subtraction sign should be a perfect square. I need to group these terms together, however. So I'm going to undistribute this group right here. This is a perfect square trinomial. Now I have my dose. 2 terms, both squares being subtracted. I can now factor this. P in front, q plus 2, q plus 2, addition sign, subtraction sign. But hold on, because those 2 need parentheses. Let's clean up my answer a little bit. P plus Q plus 2, that's okay. This one I'm going to distribute the negative. That. Decide whether this polynomial is a perfect square. If it is, factor it. Well, for this to be a PST, perfect square trinomial, I need to look at the first term being squared, and it is, it's 2 squared, and this one being a perfect square, and it is, it's y to the third squared. Is this term inside, or this middle term, twice the product of these two? Well, 2 times y to the third is 2y to the third. Is it twice that? Yeah, it is. I got 4 here. So I'm good. This is definitely a perfect square trinomial. Now I can factor it. My first term is 2. My second term is y cubed. And I'm going to use a negative because there's a negative sign right there. Determine if this is a perfect square trinomial. If it is, factor it. Right away, I know this is a perfect square. It's written to be that way. And the last one right here is a perfect square as well. Is the middle term twice x plus 1 times 1? Well, is it twice x plus 1? Yeah, right there. So that means it is a perfect square trinomial, and we can factor it. So what does it factor to? I put the x plus 1 and the 1 back here. I'm going to separate it with an addition sign. Let's clean it up a little bit. X plus 2 squared.